3-5, working with sets. So in this section, our objective is to write sets and identify any subsets and to find the complements of a set. Essential understanding, sets are the basis of mathematical language. You can write sets in different ways and form smaller sets of elements from larger sets. You can also describe the elements that are not in a given set. So in this section, we're primarily going to be dealing with different ways and different notation of representing sets of numbers. There's two basic ways to do this: roster form and set builder notation. So roster form is one way to write sets. Roster form lists the elements of a set which within two braces. For example, we write a set containing 1 and 2 as 1, 2, just like this, with our two braces right there. Not parentheses, which would indicate a coordinate. Okay, so this is why we use braces, is to differentiate from other types of mathematical symbols. And you write the set of multiples of 2 as 2, 4, 6, 8 with these 3 dots called ellipses, which means that this set continues to go and go and go and go and never stops. Set builder notation is another way to write sets. It describes the properties of an element that an element must have to be included in the set. For example, we can write this set of 2, 4, 6, 8 continuing in set builder notation as this thing right here. We read it as the set, that's what the braces mean, of all real numbers x such that, so that's what this x right here means. It indicates that that's our variable. This line up and down means such that, and here's what it tells me what x is doing. X is a multiple of 2. Okay. So roster form is a little simpler. It just lists it, right? Think of the roster of a team or whatever, right? You just put everybody, write down everybody that's on the team, okay? Write down every number in the set, or use ellipses to tell us which way the set goes. For set builder notation, we have to describe the elements of something that could put us in that set. So, how do you write T is the set of natural numbers that are less than 6 in roster form and in set builder notation. So first of all, most sets we're going to write are going to be capital letters. We're going to put our brace, and then natural numbers, means counting numbers, that are less than 6. So that's 1, 2, 3, 4, and 5. 6 is not less than 6. Okay. Close my brace. And there's my roster form. For set builder notation, we're going to say T, my variable x, such that what is happening to the variable. So x is a natural number. Oops. Comma, x less than 6. I'm going to run out of room, maybe a little bit. Okay. So with the set builder notation here, I'm sort of describing my variable, x, such that what is happening, x is a natural number, describe the limits on the variable, comma, my other limit on the variable is x is less than 6. So in this case, I have two limits on my variable to describe what's going on. Let's try another one. N is the set of even natural numbers that are less than or equal to 12. Roster form, set builder notation. Okay, so we have n is equal to roster form. It says natural numbers, again, those are counting numbers, less than, oh, sorry, even natural numbers. So just the even numbers. Less than or equal to 12. 2, 4, 6, 8, 10, 12. So there's my roster. Okay. For set builder notation, and let me put it down here so I don't run out of room again. Ooh, whoops. We're going to write my variable x. Going to put a line straight up and down. That means such that. Now we're going to describe the constraints on the variable. So x is an even natural number, comma. What else is one of my constraints on the variable? X is less than or equal to 12. Okay, with that information, I could figure out every thing that is going to be in the set, every element that is going to be in this set. Okay? We can use set builder notation to write the solutions of a linear inequality. Okay? So when we do this, I can use, first I'm going to have to solve this inequality, and then I can use set builder notation to write all the solutions of this particular inequality. So let's solve it first. Negative 5 x plus 7 is less than or equal to 17. Subtract 7 from both sides. Negative 5x is less than or equal to 10. Divide both sides by negative 5. Of course, remembering my most important rule is that when I multiply or divide a negative number in an inequality, I have to reverse the inequality symbol. So I have that x is greater than or equal to negative 2. Well, this is a little bit easier because there is no constraints on the variable. Okay, so when I look at my set builder notation, x can be anything that's greater than or equal to 2, which is b. Not set builder notation, not set builder notation, and this one says less than or equal to negative 2. Okay. So this one would be correct. It is the answer of my inequality, but it's not written in set builder notation. Sorry about that. It's not written in set builder notation. Okay. So in set builder notation, how do you write the solutions of this inequality? So let's write 9 minus 4n is greater than 21. Subtract 9 from both sides. That's negative 4n is greater than 12. Divide both sides by a negative number. Remembering to reverse the inequality symbol to get n is less than negative 3. And in set builder notation, I can write that as n such that n is less than negative 3. Or, yeah, that's fine. Okay. And I can use n as my variable, or I can rename it with a different set. Okay, so we know that a set A is a subset of set B if each element of A is also an element of B. For example, if B is all of these things, negative 2, 1, 0, 1, 2, 3, and A is negative 2, negative 1, 0, 2, negative 1, 0, 2, because all of A is in A is in B, we can say that A is a subset of B. And the symbol for that is this. Okay, subset. The empty set or null set is the set that contains no elements. You might have seen us use this symbol before for no solution because it is the solution set is empty. There's nothing in it. No solution. So the empty set is also a subset of every set. Use the 0 with the slash through it, or the empty set. I tend to use that one because it's a little easier to draw, okay, than the empty set. So, what are all the subsets of 3, 4, 5? So first, we have the empty set. Next, let's list every subset with one element. So my first set is 3, then 4, whoops, not with a comma there, one element set, then 5. So those are all my subsets with one element. Let's list the subsets with 2 elements. So that's 3 and 4, comma, 3 and 5, and 4 and 5. Okay? It's not a different set if you write them backwards, and mostly you should be writing sets in numerical order. And then finally, there is one more set that is a subset of 3, 4, 5, and that is 3, 4, 5, right? All 3 of them are a subset, right? The whole set is a subset of itself. Okay? So there are 1, 2, 3, 4, 5, 6, 7, 8 subsets of this particular set. What are the subsets of set AB? Of the set ABC? Well, P is going to be 0, A, comma, B, comma, A, comma, B. And S is going to be nothing, A, whoops, comma, B, comma, C. A, B, comma, A, C, comma, B, C. And finally, move this down for a second. And finally, A, B, C. My braces get uglier the faster I try to go, but you get the idea. So let A equal x such that x is less than negative 3, and B equal x such that x is less than or equal to 0. Is A a subset of B? Well, if we think about it, we have to ask ourselves, is every element of B, A contained in B? Is this true? And the answer is yes. Because this set starts, if you think about roster notation, this set starts at negative 3 and goes down. This set starts at 0 and goes down. So everything in here is going to be, or everything in A is going to be in B. They overlap. Okay. When you're working with sets, you call the largest set you are using the universal set, or the universe. The complement of a set is the set of all elements in the universal set that are not in the set you're talking about. You denote the complement by putting this little tick mark above the A. So it's A and A complement. In the Venn diagrams below, the U represents the universal set, and notice how A is a subset of the U, right? A is inside the universe. A is inside this light green, right? And the complement of A, everything that's not A, is now this new darker green color, okay? So here is the whole set. Here is the A, and then everything inside the U that is not A, the complement of A. Okay? So the universal set is king, queen, bishop, knight, rook, pawn. King, queen, bishop, knight, rook, pawn. Okay? And A is the set of chess pieces that move side to side. And you can see if you don't play chess, you can see how each one of these pieces actually move. So what is the complement of set A? So let's make a little Venn diagram. Okay? So I'm going to make a nice little rectangle. Okay? And then I'm going to make let's make a circle inside of this. Okay? And what I'm going to do is move this up a little bit. Okay? This is my universe. Okay? So now let's think about the set A are going to be the chess pieces that move side to side. Well, if I look at this diagram, I can see that the king can move side to side. So that's going to be king. Okay, the queen can move side to side. Okay. Bishop, no. Knight sort of does this little weird L-shaped move. But the rook can move side to side. Okay. Which leaves the bishop, the knight, and the pawn not inside the set. Okay? So that means that A prime, A complement, is going to be bishop, knight, pawn. Okay? Let's do one last got it problem. The universal set is months in a year. And set A is the months with exactly 31 days. So that means what is the complement of A is going to be every month that doesn't have 31 days. Write your answer in roster form. Not a really good way to write this in set builder notation. Okay, that would kind of be more confusing. So set, what is the complement of A? A prime is going to be equal to February, has 28 days, April, June, September, whoop, and November. All are months with 30 days, except for February, which has 28. Okay? So, our quick lesson check. How do you write G is the set of odd natural numbers that are less than 18 in roster form? Well, that would be 1, 3, 5, 7, 9, 11, 13, 15, and 17. And then it would be in set builder notation, G is equal to, put a brace, X such that, describe what's happening. X is an odd natural number, comma, what else is happening to it? That X is less than 18. Okay. In set builder notation, how do you write the solutions? D plus 5 is less than 8. Well, solve it, add 5 to both sides, and we get that, or sorry, subtract 5 from both sides, and we get that D is less than or equal to 3. So you would say D such that D is less than or equal to 3. Where are all the subsets of 4, 8, 12? I don't want to write these all out, but it's the empty set, or the null set, set 4, set of 8, set of 12, 4 and 8, 4 and 12, 8 and 12, and then 4, 8 and 12. Given that the universal set U is equal to seasons of the year and W equals winter, what is the complement of W? What is W prime? That's everything that's not winter. That's spring, summer, fall. For 5, vocabulary, what is the complement of A prime? Well, the complement of A prime, if A prime is the opposite of A, the complement of A prime is just plain A because it's everything that's not in A prime, so it's going to be A. Is the first set in each pair a subset of the second set? Is this a subset, or sorry, the first set? Is the first set a subset of this? Yes, the empty set is a subset of everything. 1, 3, 5, a subset of 1 and 3? No, 5's not in there, so not a subset. 3, a subset of this? Yes, 3 is inside the second set. A non-empty set that contains at least one element. Given non-empty sets A and B, suppose that A is a subset of B. Is B a subset of A? Well, that could be sometimes true because maybe they're both the same thing, then they're subsets of each other. But maybe A is like this example right here. A is a subset of, let's call this A and this B. A is a subset of B, but B is not a subset of A. And then finally, error analysis. Student says sets A and B below are the same. What error did the student make? Uh, whole number includes 0. Don't forget that. And that is 3-5, working with sets.